necessary, and then like Ruby probably, right?
Right, yeah. And actually today, towards the end, we'll talk about some legal stuff here. But today, we're continuing with, in fact, we're concluding with JDBC here. And we already looked about how to get stuff out of the database. Today we're going to look about how to put stuff into the database. And as far as SQL is concerned, that means an insert statement, right? So let's go ahead and look at. We've got all these directors here. Dennis Villanueva is one that I put in in this morning's class. We can look at all the films that we've got as well. It's going to take a little bit. I don't know why it's taking so long, but there we go. He directed Dune, which comes out later this year. And so I created another new film here. Black Widow releases later this year. It was directed by Kate Shortland. I just looked that up right before we got here. Now, if this were just MySQL, of course, I would formulate a query and I would do insert into film, right? Let me go ahead and describe the film table again. What's required here? Well, the film ID, that's auto-generated, so I don't want to touch that, right? If I were hard coding, test data, then yeah, I might want to hard code those values. But now this is my actual Java application. I'm going to let it do its key management. We need a title because that's not nullable, and we do need an EIDR. Don't worry about that. I think that was our. I'm not going to go that far, but we will need like a dummy value for it just to get it to work. But otherwise, what else do we need? A director ID here. So if I were to do this in plain old SQL, I would do insert into film, title, EIDR, and director ID, and then values, and then I would hard code these values. But since this is JDBC, and I'm doing this programmatically, I'm going to be using parameters here. Remember that parameters are the question marks. We prepare our statement, and then we set those parameters and then execute that statement. But in this case, it's an insertion statement, not a selection statement. You had a question?
Oh, I was just wondering what the null value is, what you said those were again. Sorry.
I mean, this is not allowed to be null. So we have to provide this data. Okay? So I've got over here a save data class. It's kind of like the load data class. And I'll show you over here that I've also modified the film and the director class so that their primary key values that are associated with the database are big I integers. And I've got these additional constructors where I can construct them with missing values so that I can create a director and a film, like I've done over here in save data, that has no connection to the database, right? It only exists in the Java world. And I want to persist or save that data to the database. All right, so I want to go ahead and start by creating a save function for films, right? So public static void save or insert film record, save film record if you want, whatever. Insert film because of course it's JDBC insert, right? And we're going to take a film record f. And let me go ahead and call this function insert film f. We're going to insert Black Widow, the film Black Widow, into our database. Right? It's not currently there. Remember, we only have these 4 films: Eraserhead, Hateful Eight, and Star Trek and Dune. Okay. All right. So help me out here. Do you remember what the basic process is? First of all, we're not going to load the JDBC driver. That's archaic. We're using a new enough Java that we don't have to do that. But we're going to make a connection to our database using the URL, the password, and the username, etc. We're going to create and prepare our query. We're going to prepare the query and then execute the query and then process the results if necessary. Then we clean up. In other words, we need to close our resources. Okay? So what I'm going to do is I'm going to take and start copy pasta some stuff over here in the example that we did last time. So make my connection, right? And again, this is so common. You do this each time. You might as well put this into a method and a factory method that does it for you. Right? Here's my query. String query is equal to. Now, I originally wrote it over here so that I could, you could test it. If I had actually hard-coded values over here, test values. But over here, when I transfer it, of course, I would not be able to execute this because question marks, it doesn't know what those are. But over here in JDBC, it will know what they are eventually. Okay? Give myself some more room here. There we go. There's my query. I need to prepare my statement. So prepared statement, PS, is initially equal to null. And remember that everything has to be surrounded with a try-catch statement here. Right? And so I will go ahead and prepare the statement. PS is equal to con dot prepare statement query. Okay. Now, I need to set these three values here because question marks, you can't insert question marks into the database. You can insert like a string representing a question mark if you really want to, if there were a movie out there with, a question mark in it or something. But let me go ahead and import this. There we go. Hopefully that was right. Yep. Remember, all java.sql, it's all in that API library, Java JDBC API. All right. Now, ps.set, what is it, parameters? Well, actually, you set it according to the type here. So the first one corresponds to title. So .set string. And the parameter indexing, remember, starts at 1. That's the weird thing about JDBC. There are no named parameters. So the first one is 1, the second one is 2, 3, 4, etc. And we set it equal to the title. The title here is of this film here, f.getTitle. Again, if I were hard coding this stuff, it would be Black Widow. But I don't want to do that. I want it to be whatever title you gave me in that input film. So f.getTitle. The second one is an EIDR, so .set string, same. 2, but I just need some random value here. So I just mashed my keyboard. Again, you may even want to design like an external tool that goes out to the EIDR websites and actually pulls that data. It took me forever to find one of them because there are so many duplicates and cross-references. But in any case, I'll just go ahead and use that as a placeholder value here. The only reason that we need to do that, again, is because we designed our database to make it required. Right? And it's a unique key, unique. Right? The last one we need to set is an integer, because that's what a director ID is. Right? So let's go ahead and try that. 3, and then the film dot get director. Remember, it's a full object, so it's not just the director ID or code or something like that. It's an actual object. Dot get director ID. Okay. Then finally we need to execute our statement. So ps.execute update. Right? Now, it's execute update, it's not execute insert. Execute update is for anything that modifies or writes to the database. So insert statements, update statements, delete statements. You would use execute update. If you remember from last time, once we prepared our statement, if it's a select statement, then execute query is the function that you want. That returns a result set. In this case, however, it is execute update, and it'll save to the database. Once we're done, we need to clean up our resources. So ps.close and con.close. At this point, you'll notice that I don't have a result set because I'm putting stuff into the database. I'm not querying it out of the database. All right? Excellent. So everything compiles. Let's go ahead and try to run it and see if it actually works. Oops, null pointer exception at line 30. What was wrong here? The director was not null. Kate Shortland we've got right here. So the film was definitely not null. The director was not null. But what about the director ID? Here is my constructor that I called, new director. What value did I set for the director ID? Null. That's because it was not in the database. This is a record that doesn't yet exist. I'm writing this function so that it persists to the database, and only after it persists to the database does it have a valid director ID. Right? So we're kind of at an impasse here. What should I have done first before I inserted the film record? Remember, we've got a director-film relation, parent-child relation. Can a parent exist without a child, or can a child exist without a parent? Nope. We need this director record here, Kate Shortland, to be in the database. She's not. So what I could do is I could go ahead and formulate a query over here, insert into director first name, last name, values, question mark, all right, and hard code those values to Kate Shortland. But I want to do this programmatically. So, do you see a way of doing that here? No. But it sure would be nice if I had a function to, well, check, or in this case, insert a director, right? Well, if it sure would be nice to have that, then gift it to yourself, right? Once you get past a certain age, nobody buys you gifts for birthdays and Christmases. So what do you have to do? You have to give it to yourself, right? Yeah.
What if that director already exists in the database somewhere? Wouldn't you have to create some sort of conditional check for that?
Good question. Let's come back to that. Okay. So insert director. Right? Okay. And director D. Kind of like this. All right, just similar to the insert film, we've got insert director, and then we take the director here, and we insert the director. Now, you make an excellent observation. What if we were inserting yet another Quentin Tarantino movie, and that director already exists? Should I go ahead and insert Quentin Tarantino again? No, that'd be a duplicate record, right? And if we've got constraints against that, for example, the constraint that we have for the EIDRs, right? That is a uniqueness constraint. We would even be prevented from doing that. Now, there might be two directors named Quentin Tarantino and Quentin Tarantino, right? But we probably don't want that. So let's rethink insert director. I like your idea of reconnection successful. We're up to 900. Okay, we're back up to 2K. All right, or 2000K. All right. Sorry, hopefully we didn't lose too much there. Anyway, here's our documentation so far. This method returns the director with the given first name, last name, if in the given director D, loaded from the database. If no such record exists, it persists it to the database and then loads it. All right. Great. So it sure would be nice. This is basically three interactions with the database, right? It's a select query, and then if your result set is empty, then select based on the name. Select from director where first name is equal to this and last name is equal to that. And then if it doesn't exist, then we need to insert it, and then we need to load it up again, right? Once it's been persisted to the database, because now it has a director ID. Gee, it sure would be nice if I had a method that got a director by their name. Right? And I've already done that over here, load data. Remember last time we did get director by ID? This morning, I just kept it from this morning, we have get director by name. The way that it works is just as I said, select director ID from director where first name is equal to and last name is equal to. We set those to the first name and the last name. We execute the query. If, in fact, it exists, if the result set has a result, then we get the director ID, create a new object based on those three things, and eventually return the result. Otherwise, no such director exists, we return null. Instead of throwing an exception, right? Now we have a design reason to not throw an exception. Or in the calling code, we could try catch an illegal state exception and then determine, oh, that doesn't exist, so I'll go ahead and do this, right? In any case, it's already written for us, get director by name. So I'm going to go back over here to save director, and director existing director is equal to load data dot get director by name, and I'll just pass in D. Now remember how that worked. If it's null, then we know that we need to insert the record. So if existing, don't want to type, existing director is equal to null, then to do insert the record. Reload it. Otherwise, if it already exists, what do? Return it, right? Return the existing director. That way we will avoid problems with duplicate records. And of course that means that we need to change the return type here now to director. Right? And it's going to complain about this because we haven't done this part yet. to do. Insert the record, reload it. Okay? So now let's go ahead and take care of that. It's going to look very, very similar to all this stuff. Copy, paste. Too much copy, paste, right? There we go. So I make a connection. I insert not into film, but I insert into director. First name, comma, last name. Values. And now here there are only two things that I need to insert. If you get that wrong, or if you've got X columns and you have Y parameters and the X is not equal to Y, an SQL exception will be thrown. If you've got 5 parameters and you only set 4 of them, the 5th one is still question mark, an SQL exception will get thrown, et cetera, et cetera, et cetera. Right? If you've got a lot of these things, right, then it can get quite confusing quite quickly. Right? But the SQL exception is sometimes helpful in that it says the 5th argument of this prepared statement is not specified or something like that. And you could go back and fix it. I've got a prepared statement here. I query it. Set string. This is no longer first name, last name. It's d dot get first name and d dot get last name. There we go. And not this. Execute update, close, close, close. Right? Otherwise, we throw an SQL exception. At this point, it's in the database. We need to load the new record. Dot, dot, dot. Go ahead.
So, like, you open those connections with databases quite a bit here. Would it be like a good idea to pass down the connection?
So an ugly secret of your current project is that it's definitely not multi-threaded. So from that perspective, you could have one connection that everybody uses it. Right? Now, you can't do that. You could do that. Right? One persistent connection that never gets closed until the end of your program or something. And then you're not opening and closing connections all over the place. That pattern should not be used in practice. Instead, what you want to do in practice is what's called a connection pool, because opening a connection can be quite expensive. Closing a connection can actually be expensive. So if you've got a persistent program that runs, like a web server or something, it's always running, you don't open, close, open, close, open, close. You open 30 persistent connections and put them into a pool over here. You check them out like library books. And you don't close them. Once you're done with them, you put them back in the pool. It's a pool of resources that threads can use. Now, if you're going to do something like that, then definitely use a library. The one that I know of is called C3PO, named after the Star Wars character. And that would allow you to use connection pooling. Otherwise, something like JPA will have connection pooling built in, and it's all under the hood. You don't even need to worry about it. But that's what you would do in practice, especially in a multi-threaded environment. We're not in a multi-threaded environment here. But also take it from another perspective here. You've got method 1, 2, and 3. If you had a shared connection, but there's some dependency, like the method 1 calls method 2, or something like that, or somebody only ever uses method 1 and never uses these other things, right? Then that ensures that the connection is limited to that method only, the way that I'm doing it here. I open my, it's all a matter of who is responsible for resources, just like who's responsible for cleaning up memory in C, right? Whoever owns the link to that memory, whoever owns the connection is responsible for cleaning it up eventually. And so I'm limiting the ownership to each method, meaning that I'm going to open it and close it immediately when I'm done with it. And that's just a common design pattern. Okay. All right, so let's load up the new record. Well, if it's definitely going, if the insertion failed for whatever reason, what would happen? An SQL exception, we'd throw a runtime exception, right? But if we got to this point, and then we'd kill the program. If we got to this point, what do we know? We know that it was successful and that it's in the database. So what could I do? Exact same thing as I did up here. Here's the new record. New record. Right? Get it by name, right? And then I can return it. Right? Now, like you observed, that's opening up yet another connection. Connection to check to see if it exists, close it. Connection to insert it, close it. Connection to get it again once you've inserted it. That's option 1. Option A, reload it. Right. Here's another option. I'm going to promote this back up over here. There we go. Right. New record equals null. There. Okay. What we could do is once we've executed this update, I could ask the database, that record that you just inserted, what key was generated for that record? Right? So ask the database what PK, primary key, was just generated by the previous statement. Now JDBC does support this. The way that you do this is by preparing a different type of query. So what I'm going to do is I'm going to insert another statement here. Statement.generate, return generated keys. Now this, oops, that's not what I wanted. There we go. And import java.sql.statement. There. Now this is an added piece of functionality. So an added flag at the end of this prepared statement. Still prepare the same statement, but also I want to configure you so that when you insert a record, also ask the database for the keys to be returned. Key or keys. If I was inserting multiple records, 5, 10, 15, 20 records, then it would give me all 20 of those keys. In this particular instance, I'm only inserting one record, so I'm only expecting one key to be returned. Okay? So once I've executed the update, I can ask for a result set. RS, or I'll go ahead and call it keys here, is equal to ps.getGenerated_keys. Right? Does what it says in the box. Right? And let me go ahead and import this. There we go. Once I've got the keys, that's a result set. Remember result sets, if there are 5 results in your result set, initially a cursor is pointing before the first one. So you use rs.next, or in this case, keys.next, to point to the first record. Keys.next, point to the second record, et cetera, until you get down to the last record, beyond the last record, at which point rs, or in this case, keys.next will return false. So if it were a loop, of course, I would go into a while loop, while rs.next, next, and I would process each record. In this case, though, I'm only expecting exactly one record. So rs.next. Not rs, sorry, keys. Now, you could put this into an if statement. And if you don't get a record out of it, then something seriously went wrong and you can throw an exception. Right? In fact, let's do that. If keys not next, then I'll throw a new illegal state exception. Wow, something went wrong. The record appeared to be inserted, but I didn't get my key. That should never happen. Right? It should probably result in an SQL exception of some sort. Otherwise, it does, semicolon, sorry. There we go. Otherwise, keys.next will advance to the first and only record, hopefully, and I can get the value there. So int director ID is equal to our keys.get the first and only column. You might be able to use a named column here, and it is an integer. Sorry, not just get, but get it as an integer. You can create keys that are varchars. You should not. It's very bad practice to do so. But otherwise, I've got director ID here, which is an integer. And now I don't have to make yet another connection in order to get it. Right? I'm simply reusing the prepared statement here, and then reusing the same connection. So I've cut it down from 3 connections at least to 2 connections. Yeah.
that sounds like something I did. Are you able to like give a suggestion on what I could do instead of that?
Well, I guess I would, I'm not sure what you mean by that, but I guess you should ask yourself questions like, gee, it would be really nice if I could get a person record by their code rather than their first name, last name, right?
Yeah,
And that's a gift you can give yourself.
like, well, yeah, but like the CSV data, as in addition to that, I was also thinking the CSV data comes with like a person code and item code.
Right.
So how should that relate to what?
Exact relation as an EIDR, right? It's a natural key, which is external from our database. So it should be used, it should be kept track of, it should be unique, it should be indexed, but it shouldn't be our primary key. Primary keys should be our surrogate keys, the ones that are generated by the database.
Okay, thank you.
Exactly like you would do an EIDR, like we did with an EIDR. Right? All right, so I've got my new record, and ultimately I will return that new record. Great. I am now done with the director. What I can do now is use that over here in the insert film. I can go ahead and create a director. D is equal to, what did I call it? Get or insert director. F dot get director. There we go. And now down here, instead of where this was originally null, I can go ahead and go D dot get director ID. Right? And I don't have to worry about, is the record already there? Well, I've got this function over there that either gets it or inserts it and then gets it, and I'll let it worry about that stuff, right? And I'll do it over here instead. Okay. Now let's go ahead and run this and see if it works. There. No news is good news. Don't worry about that yet. That warning. We'll come back to that. But let me go over here to my MySQL workbench. The insertion of Kate Shortland, the record for Kate Shortland, is there. And the Black Widow record is now there too. So, successful. Right? I don't know who she is, so what else is she directed? Black Widow 2. Eventually, right? Yeah, because it's so popular. Right? All right, so if I ran this again, of course, her record would already exist, so I would not have a duplicate record over here in the director table. But then I would have a new, I hacked her with name Shortland Kate, and I issued that warning, and that's when it inserted the record. I should not get this warning the second time for Black Widow 2, right? When I run this, oops. Oh, duplicate entry. All right, fine. 1. There we go. And now it should work. Good. Again, there's not going to be a duplicate record over here for Kate Shortland, but now there should be Black Widow and Black Widow 2. Excellent. And now I can do this programmatically. I could load stuff from the CSV file and persist it to my database, right? And that's what you'll do in 2 phases from now. Okay? All right, any questions on this? Otherwise, this will be posted along with all the notes. One other thing that I am going to refactor this a little bit here. I'm going to promote this result set, these keys up here, to be up here is equal to null, so that I'm not redeclaring it down here, right? I just straight up closed. First of all, I forgot to close the result set, rs.close. Right? But also, I'm going to refactor this just a little bit. Not rs, but keys. I'm going to refactor this a little bit. Now, understand what a try-catch does. If an exception, say, occurred on line 52, what would happen is that the exception would be thrown, and we would take control over here at line 57. We'd rethrow it, and of course it would be fatal at that point. Eventually stuff might get cleaned up. The connection may be persistent beyond our program though, because the database might be sitting there saying, okay, well, you've got 5 minutes, and if I don't hear anything from you, then I'll close. It's sitting there, staying open for 5 minutes. And I never got to close it because I immediately jumped from line 42 or whatever it was down to line 57. So one way that you can handle this is by following a different pattern. So there's a try, there's a catch, and then there's another thing that can go after it. You could do another try catch, but finally, you can add a finally block. Right? A finally block is executed regardless of whether or not an exception was thrown. So even if an exception is thrown on line 42 and takes over here, this finally block will actually be executed before the exception is thrown. That's where you clean up resources. Now, not only that, but you also have to understand that, well, what if keys never got opened because we threw this exception on line 42, so therefore we never actually instantiated it. That would end up being a null pointer exception right there, and we would never get down to these other three. So you can check to see if it's not null and if it's open. If keys is not null, because you don't want to be doing anything with it if it's null, and keys dot is closed, right? If it's not closed, and we don't do and like that, too much Python lately. There. That's a nice little pattern to follow. If it's not null and it's not already closed, then close it. Because if it's already closed, why close it twice? In fact, it might even throw an exception if you try to close it twice. Just like with memory, once you free it, if you try to free it again, it may result in a segmentation fault in C. Okay. Now to do that, that means that I need all of these things up there. Why are you complaining about that? Oh. All right, so let me go ahead and finish this out. If PS is not equal to null and not PS dot is closed, then go ahead and do it. So likewise for the connection. Copy, paste. Con. In fact, that is such a, copy, paste. Maybe I could even have a factory function to close this stuff for me, right? And it'll take care of it for me. Going beyond that with factory functions, don't do that. Then you'll find out that you are reinventing an ORM, an object relational mapping system. It's complaining about this because even closing something may result in an SQL exception. So ultimately what I have to do is I have to try and catch all this garbage. Right? And then I could put in another finally and then try it again, realizing that it'll throw an SQL exception. It's this level of deep, that's as far as you go, right? If something truly happens with closing resources, then you are out of luck. You're SOL. Right? And so let it go ahead and be fatal. Fine, it'll reset itself in 5 minutes. At most, I have to wait 5 minutes, right? Or whatever the timeout is. Okay. All right, that looks good. Anything else on that? I don't think so. So again, dealing with SQL exceptions. We talked about this last time, but I said that we didn't have enough time to go over logging, and you saw that as a preview there. Let me go ahead and go back over here to load data, and I'll show you that I've already configured this to load up this director, which doesn't exist, director with ID -42, print them out, and then print all the films out. So let's go ahead and run this one and check out the output down here. That doesn't look like, I mean, it is standard output, granted, but the reason that you don't want to use system.out or system.error or system.in, well, it was because nobody's sitting there, right? Nobody is sitting there looking, can't find director with ID -42, to the keyboards we go, right? Nobody's doing that. Instead, what you want is a proper logging system that logs to files or that persists to a database so that you can look stuff up in the database. Or if it's really serious, action needs to be taken right now, the server is down or something like that, it could be configured to email somebody about that or beep them or something, whatever, right? Many, many different configurations exist to do this. But standard output is not one of them. Right? Standard output is just standard output. It's just being dumped to the standard output, probably being ignored. So a proper logging system allows you to have more fine-grained control over that stuff. And the one that I've set up here is Log4j version 2. I downloaded this morning, and I didn't bother deleting it. But you do need the API and the core. I ended up downloading it. I'll show you really quick here. If you just search for Log4j2, don't use version 1. Use the updated version. I don't think it's actually been updated. It might have been updated recently. But in any case, you can download it. Oh, where is the download? Right there, there's the download. Once I downloaded it, then we looked at it comes with a whole bunch of jars. Which ones do you need? You just need the API and the core. Once you've got those in your class path, then you can start using it. The way that you use it is you create a logger. Now usually there's a logger per class, not per instance. In this case, I've got a private static final logger, and the logger is a log4j logger. There. Everything is in org.apache.logging.log4j. Right? I am loading this. The log manager is attaching this logger to this class. It would be kind of weird if I put save data. You could do this, save data, right? Now that's a logger for save data, but it's part of the load data class. It doesn't really make sense, right? So each class generally has its own logger. It's static, it belongs to the class, so that there's only one logger per class. Then what I've got is a configuration here. A configurator, just initialize it with the default configuration and set the root level here to be info. Remember that there are several levels that you can have. The highest level is going to be fatal. A fatal error happened, email and alert everybody because the system is down. Beyond that, you have errors. Right? So for example, let's see. I'll show you how to use it down here. Once you've got your logger, you can go logger dot error. Right? Not at error, but error. Something happened, right? You can wrap that up in like if you've got an exception, you can give that off to the logger, and the full stack trace will be included. You can have an arbitrary message that gets output to the log system. Lower than that is information, and that's what I've got right here. I'm starting this. I'm starting this program. User 579 logged in. User 872 logged out, right? You would log information that is vital to the system that you care about, that you want to eventually say, you haven't logged in the last 5 days. Why, right? Or so-and-so logged in, though they were on vacation, so what's going on there, right? Whatever information you're trying to audit. Below that, you've got, I think, trace and or debug, and I'm not sure the relative order of that. What you can do, what I've done here is I've set the default level to be info, right? And you like these different levels because when you push it out to a test server, maybe you want everything to be logged because you are actually debugging stuff. You want to know what happened if you encounter a bug or an error. But when it goes out to the production system, you don't want all that debug information. And so you can shut it off by defining what level there is. You can even define your own levels. You could define like debug level 1, debug level 2, and debug level 3, and then set a hierarchy somehow. You could change, this is the default configuration. It simply outputs the timestamp, the method that it occurred in, the level of the warning, the fully qualified package and class name, and then finally the message. Right? You could change that so that it formulated a full date. This is just a time, but you have very, very fine grained control over this stuff. And that's what using a proper logger system looks like. Right? Log4j is still the de facto, even though they've kind of almost incorporated it into core Java by now. Right? It's still better. So I would suggest using Log4j. Let me go ahead and put that in the notes, but suggestion, use Log4j version 2. There you go. All right. And the example will be in the code when I post it. All right. Any questions so far? Otherwise, I did want to show you one other thing before we move on here. Again, since this is a truncated semester, I'm not going to cover JPA, but I do have a video on it, and I've got a not a bonus, but an extra lab 10.5 that walks you how to use JPA. I just wanted to show you what it looks like in, this is an old project here from another year, and this is, but it also had addresses, right? Everybody has addresses. So this is what JPA actually looks like. These are called annotations. The @ sign, and then the entity, that's actually a Java class right here, right? That you can actually open up and look at. But what I'm saying is that this address class, it's an entity that has some connection to the database. What is that connection? Well, you associate this with the address table. And so now you see why I prefer the modern convention of using upper camel casing for table names, because there's no guesswork, right? You're eventually going to have Java classes in your code with the same names. Just go ahead and, don't name them two different things. Right? How does it work? Ooh, what do you think that is? ID. It's a primary key. I'm saying that this column is the ID, the primary key. Right? It's generated. How is it generated? Auto-generated, just like MySQL. The column that it's associated with in this address table is address ID. Right? And is it nullable? Nope. You can have a street, city, state, zip, country. Right? And once you've annotated it, now what you can do is you can just simply tell JPA, load up everything for me. Right? Save everything for me. You don't write a single line of JDBC code at all. What might that look like? I'll just show you really quick here. If I can remember where it is. Database data loader. There we go. There's what a JPA query looks like. Kind of looks like an SQL query, from Portfolio. But that's not SQL, is it? It's not select star from Portfolio. It's just from Portfolio. Give me everything. Give me all the portfolios. EM is the entity manager. I create the entity manager. I begin a transaction, and I let it take care of everything, right? Those maybe 100 lines of code where I would have to select everything from address or portfolio or whatever and go through and process each result, it's now taken care of for me. And you can see that this is, in fact, Java code because I can actually it takes me to the portfolio class when I click on it. It's self-aware that that was a JPA entity right there because of that magic little annotation. Right. So if you want to use JPA for your project, go ahead. You might need to stop by office hours to get some help on how it can be done. But if you, definitely as a first step, if you're going to do this, definitely watch that video and do that lab and get that working. Once you've got that working, then it should be pretty straightforward to do it for your project. Again, you don't have to. Right? Yeah.
If we do end up not using JPA, like you said, like it basically saves us thousands of lines of code. Like that seems like a pretty tedious process. Do you actually recommend like not using JPA? Because like it seems like I think you said like last week or so, like if we did it like with like all person.
If you were doing full CRUD, right? Create, retrieve, update, and destroy for every table that you have. How many tables do you have? Maybe 10, 12. If you were doing full CRUD, that is at least 48 methods that you have to write. Right? You're not doing full CRUD though, right? You're loading them up, and then you're implementing our API in the second to last phase. Right? So you're not doing full CRUD. You're not, in particular, you're not doing update. You're doing destroy, but you destroy everything in that API. You're not destroying one particular thing. Say what?
So basically, do we have to write thousands of lines for that instead?
No, I mean, I'm not going to look it up, but I think my version is maybe 2,000 lines of code without JPA. Yeah.
How would you go about like
That's a good question. Well, address is a special thing, right? You could argue one way or the other. You could argue that it's a one-to-one relation. You could argue that it's a many-to-one relation, that many addresses have one, say, store. You could argue that many stores have the same address. Neither one of those makes sense, but making it one-to-one makes a little bit more sense. But then it doesn't make sense with persons, right? You can have two people living at the same address. You can have one person that owns two homes, right? So you could have whatever relation you model there is probably going to be justifiable, right? Now in your design document, you should talk about how that supports the business model, right? We chose a one-to-many relation even though it's not necessary because it was simpler, or we chose to do a one-to-one relation because it supports the business model better, et cetera, et cetera, et cetera. Whatever you can use whatever you're going to justify it with. Again, with design, there are multiple correct solutions. You should have justification for your decision, though, right? That's an opportunity also to fill out that alternative design section, where initially we thought that we'd do a one-to-one, but it became too difficult, and so therefore, it did not add any benefit, so we chucked it. We didn't do that. We did a one-to-many relation, even though it's not a perfect mapping out to the business model. It still supports the business model, but it makes the code easier. That's a perfectly justifiable reason, right? In fact, making those decisions is all part of architecture. Yeah, good. We're good on time here. This basically marks the median point of this course. We did Java or PHP in here. We did object-oriented programming. We did database design and database connectivity. That's all very, very practical stuff. Now the second half of this course is all data structures and algorithms. More theoretical. Still, I try to focus it more towards the practical, but it's still going to be showing you computer science for what it really is. It's not just programming. It's not about computers, and it's not a science. So what is it? It's math, right? But before we get there, I'd like to use this as an end cap here, just to talk about architecture a little bit and software engineering, et cetera, et cetera. Most of the stuff that you've done up to this point has been small programs, maybe text file based. They run locally. They run on one machine. And like we talked about before, they're all single threaded, right? You might have done some thick GUI, like with GTK or Swing or Visual MS products or whatever. But there's little to no other interaction with other programs. But that's actually quite small. I mean, consumers have one view of software. It's the apps on my phone, right? That's the tip of the iceberg. The vast majority of software exists to interact with other software, right? And so the vast majority of software that's written is what's called glue code. You've got one system and another system, and you need to make them talk together. So you build glue code between them. That's maybe serialization, XML, JSON, right? And going off to another system, or some binary interface or something like that. And so once you get past the single program kind of world, a lot more large-scale questions come in. You're not talking about, I need a particular 2x4 for the stud for this wall. Now you're talking about an architecture design of a house, right? So you're no longer talking about the nuts and bolts and I need a Phillips head for this, like you are low-level programming. Now you're talking about the big picture stuff. It's a software design on a larger scale. You make use of extensive databases. It's distributed. It's multi-user. It's multi-threaded. And you need a way to organize that larger picture stuff. And the way that you can, I'm going to skip some of this. The way that you can organize this stuff is into tiers. Now, if you've got a thick client application, like an installed program, like, I'm running Adobe here, Adobe Reader, or Microsoft Office, or I've got Winamp here, right? Does anybody still run Winamp? I would if I could, but I don't have that many MP3s anymore. Anyway, now it's all Spotify. Now it's all in the cloud, right? In fact, that's a perfect example of a one-tier architecture versus a two-tier architecture. A one-tier architecture is just one tier. Everything is done on, files are saved, your Office files are saved to the same disk, et cetera, et cetera. It's all contained in one tier. Two-tier architecture introduces the client-server model. So instead of running MP3s on your Winamp, now you have a client like a Spotify client. There's no music stored on your computer. Instead, it's streamed from the cloud on the server. Right? You have the client application, and it connects to the server and sends information as needed. That's kind of like a business tier and a presentation layer in your client, but the actual data is stored in the cloud. Right? That's actually what I skipped over here. Avoid weasel words or concepts like cloud computing. We store everything in the cloud. Cloud. Right? That's just a new name for something that has existed since computers began. You're just sending stuff over the over the network, right? You don't need to call it something new. The only people that come up with a new name for something are people who need to market a product, right? So avoid weasel words, avoid fads like that. Right? It's something that's existed for a long time. I just saw today that Discord was being potentially bought by Microsoft. Everybody's used Discord? Yeah? Do you know what Discord is based on? Internet Relay Chat, IRC, something that is 30, 40 years old, right? They just put a fancy interface around it with nice colors and, and sound and stuff like that. People were doing, hashtags and @ symbols and talking back and forth in Internet Relay Chat 30, 40 years ago, right? Nothing new. But anyway, the client, the two-tier architecture has a client-server model, usually a network. You can then separate that into 3 tiers, which is what you're kind of done here with your project, or at least definitely what you're going to be doing in your lab this week and next week. The database is down here, and it manages all the data, right? Your albums database. Then you have what's called a middle tier or a business tier. Those are your Java classes that are responsible for loading and persisting data. Then up here, you've got the end user interface. And in lab, that's going to be simply a web page that displays all the album data in a nice HTML table that you can then sort and walk through. You can click on them and then go to the album songs in that album, right? That's the client tier or the presentation tier, the presentation layer. The presentation layer may not necessarily always be for human users. In fact, like I said at the beginning, most software is written not for humans, but to interact with other software. So you could be serving this up as an API like EIDR. There's a website, maybe it has an API that you can connect to and look up movies so that you can rewrite your own client and it uses that as a service. Right? The separation of tiers allows for modularity on a larger scale. Just like when you use inheritance so that you don't have to reinvent the wheel every time. You have loose coupling, a class. It has a single responsibility principle. It's responsible for one thing so that it's separated out from other things. Likewise, tiers allow you to do that at a much larger scale. If you've got 100 people development team, you don't want them all working and stepping on each other's toes. So you separate them into teams. A database team, a middle tier team, an iOS team for the front end for your iOS devices, an Android team, a desktop team, a web app team, right? And they can all work independent of each other because there is a separation of this modularity on a larger scale. And each tier can be completely different technologies, and they can all be interoperable, but with loose coupling. Right? Databases could be SQL Server, Postgres, Oracle, MySQL, and nobody, any of the other tiers should be none the wiser, right? You should not have, remember dependency inversion? The whole reason that you program towards an API is so that you don't have a dependency on low-level stuff. You can take out your SQL server, throw it away, put in a free Postgres server, and nobody knows about it up here. All you have to do is change a jar file. Right? You might have middle tiers that are in C#, .NET or ASP, JSP, Java, PHP, C++, Perl, right? Or you could even have frameworks like Ruby on Rails, Angular, right? There's an entire MVC I think that there are like 24 different presentation layer frameworks for JavaScript, right? If you just go to todomvc.com, you can see them all in action, all at once. You might have you could have thick clients that also connect to your database or something, right? Your Swing application could be connecting to your remote database and pulling data or something. You could have thin clients, which is basically just web apps, right? It's a web page that connects to your middle tier. You could also have in-betweeners. All three of these are dead. Microsoft Silverlight was for DRM only. Flash, all those nice Flash games that you could play. Flash is now officially dead. Java applets died a long time ago. I don't know. Did anybody play nice Flash games? All right. Nice Flash games. They were, yeah. They're fun. They're free. And to be able to get them, you have to downgrade. You have to make sure that your browser never upgrades, because I think the latest version of you can't even re-enable it on Firefox anymore, or maybe it's Chrome. Okay. You can go even fancier if you need to. You could have N-tier architectures, as many layers as you want, so that you can scale things. This gets into SAS, PAS, NAS, and IAS, which are software as a service, platform as a service, network as a service, and infrastructure as a service. For example, if you're a startup and you don't want to purchase tens of thousands of dollars in equipment and maintain your own servers, one solution now is to go to AWS, that's Amazon Web Services, and pay them. Use their infrastructure instead. Right? And you're not paying for your own physical hardware, you're paying for virtual machines. Network as a service. You don't want to, buy your own, lay your own cable, right? No, only cable companies do that. And so you use their network as a service, right? Everybody does that with their internet provider anyway, right? You do it on a commercial scale with your actual applications and your actual infrastructure, then that's taking it a little bit to the next step. Here's an example, like the 7-layer burrito. It's 7 layers of abstraction. You've got a database layer, then you've got a data access layer on top of that, JPA, right? You have a first level business tier for core activity or for the core level. Like the quintessential example here is banking software. And of course, you want to sell your software to multiple clients. That bank, Bank ABC, Bank USA, Bank XYZ, right? All those banks are going to have some common functionality that you can maintain, consistency across, right? Maybe FDIC requirements. But then each bank is going to have their own products that they want to sell, their own weird, potentially illegal products, right? And so you can add another layer of abstraction on top of that that has that client-specific functionality built into it. And then you can have 2 different teams on each one of those, and one of them is always maintaining the first level business tier, and then you've got separate teams that work on one client and then another team that works on another client, etc. You could have a validation layer for data going back and forth between the business tier and the presentation tier. You could have a presentation layer and then even a templating layer on top of that, because Bank XYZ does not want Bank USA's logo on their website. So we'll design a basic website and then slap a template on top of that, so we only have to tweak a few things. Use the red templating over here and the blue templating over here, change it to their logo over here, change it to their logo over here. Right? So you don't have to reinvent a layout system. Right? The core questions are, how many abstraction layers do you actually need? Right? Do we need 7 right off the bat? Probably not, until we get to a point where we do need to scale like that. Who should be responsible for what? Should we do thick client, thin client? Should we support both iOS and Android and desktop and a web app? How do we manage the data? What languages, what platforms, what technology, what software do we use, right? And to make those decisions, you have to come in with a bunch of different factors. Who's your user base, right? If there's a big difference between a very niche product with power users, and you may have only 100, possibly 100 clients. and you're competing for a very small client pool, but you're doing something very niche. Location and other requirements could come into play there. Budget, and this is usually referred to as the iron triangle of project management. Here's my triangle, right? Correctness, quickness, cheapness. You can only ever choose at most two. Because if you do it correct and quick, it ain't gonna be cheap. If you do it quick and cheap, probably ain't gonna be correct. If you do it correct and cheap, it ain't gonna be quick, right? So it's the not golden, it's the iron triangle, because you can't, bend it one way or the other and collapse it down and choose all three, right? At most you can choose two. If you're cavalier about it, I suppose you could choose none and do it incorrect, take forever, and it's very expensive. And that's the bread and butter of government contractors right there, right? And also the available resources and knowledge and hardware, right? Knowledge base there, here. Yeah, one of those things would include, how many people you actually have. Like, companies do frequently have to decide, are we going to stay where we started? Like say Huddle. Are we going to stay in Lincoln where we started? Or do we need to move to Silicon Valley because we have a need for 1,000 more employees right now? There's no way you're hiring 1,000 people overnight or even in a year in the middle of Nebraska, right? So you have those kinds of questions, like, can we actually attract the people here? And like I told the beginning of the morning class, I'll tell you one unfortunate truth is that more than half of all of the graduates of our program, CSCE, all of our programs, go out of state. They don't stay here. And it's because you can command a 20 to 30% greater salary outside the state, according to our exit data. And that's hard data, right? But you do have, then come personal decisions, right? Do I have family? One reason I stayed in Nebraska was because we have family here and I didn't want to leave that. And so it wasn't worth the extra, and I did get a job offer that was 40,000 above the highest offer that I got here in Nebraska. It was in Wisconsin. We didn't like the Badgers. We don't like the Brewers. So no, I'm not. I'm not moving to Wisconsin. Yeah. No, that's all right. I'll tell you why I came back here, though. I took a big pay cut to come back to UNL 10 years ago. I took a 20 to 30% pay cut because the amenities were much better benefits, much freer, as in I didn't have to be here exactly 9 to 5, Monday through freaking Friday, and dress code.
You're off summer. No, you're not off summer.
I am, but I'm not getting paid. If I find something to do that I get paid for, then yeah, I can be on summer.
Do you expect that less students will move out of state due to online meetings becoming more and more prevalent?
That's the ideal. Get a Silicon Valley salary and live in a Nebraska cost of living state. Wow, that's the ideal. Now, I knew a person that did the exact opposite. He got a Nebraska salary and he lived in San Francisco. This is 10 years ago, and I'm like, you idiot. But those are all the questions that go personally into deciding for jobs, as well as once you're in a job. If you're an architect and you have to make these decisions, right? These designs also might change, right? If you go from 100 users up to 10,000 users in the matter of a year, you're going to need to scale, right? You might need to introduce new layers, refactoring, migrations, right? We need to upgrade the database server. That means that you're coming in at 3 o'clock on Sunday morning, right? Because we're not doing it during a high usage time. And that's just a reality of a salaried job, right? Introduction of new techniques or new technologies may mean that you rewrite something. Right? It may be necessitated by market supply too. That again, if you can't get the programmers, or if you've got an old school COBOL system or RPG system or something in a dead language that you have to maintain, the number of applicants you're going to get for those jobs is extremely small. Right? So you're always in a constant battle to update software into stuff that is actually supported and popular. Yeah.
How do outsource companies like, well, they obviously have a contract to create something, to make something, and then
Yep.
have to maintain it?
Usually it's handed off to the company, and you don't want, you may not want a contract to build something and maintain it. The cost of maintenance is just as high as the cost of building it, but the profit is far lower with maintaining something. So, there are companies that will provide maintenance, right? You can buy maintenance, licenses from Microsoft, for example, and then you can, people are still supporting Windows 6, 7, whatever it was, Windows, not Millennium, whatever it was. And they had need to continue supporting IE6 or something like that. And so you can pay Microsoft exorbitant fees to continue to support it if you want to, but at some point they say, it's no longer worth it even if you paid us $1 million. Goodbye. Red Hat sells support, yeah. They're free, it's a free software, and their business model is that they earn money by selling their support. Right? So support as a service instead of software as a service. Right? Good design simply means that you have loose coupling so that you don't have DBAs, database administrators, stepping on the toes of the middle tier folks and back and forth. That means that you keep data stuff in the data tier, you keep middle tier stuff in the middle tier, and you don't mix. Right? You don't put your business logic into your database tier. You don't put your data stuff into your business tier. Right? You want to make sure that it's extensible. That it has loose coupling so that it's flexible, right? and all that stuff. Bad design is where that doesn't happen, where DBAs are full stack developers. Right? We talked about that in the earlier section. That's a big red flag, at least in my book. If you see a job offering or job listing, we're looking for that rock star full stack developers. What does that really mean? They're looking for somebody that's going to do the database stuff, the middle tier stuff, and the presentation layer stuff, the full stack, right? Because they don't want to pay 3 people to do it. They don't want to pay the number of people that it actually takes to do that stuff. So beware of job listings like that. We want that rock star full stack developer. I'm a full stack developer. Okay, that means that you're accepting salary 1/3 of your worth, right? Or whatever, right? And you also have the concept of technical debt, right? That if you don't choose those two from the iron triangle, then you're taking out a loan on your future time. You got to find time to do it right the first time, or you got to find time to do it over, or you're eating your own dog food. Yeah, ignore all this. Jump to the end here. Yeah. So software engineering, software development, whatever you want to call it, all 3 of our majors basically go into the same job market. It doesn't really matter. You do need to have a good awareness, at least, of software development methodologies, waterfall, Kanban. What we're using in this class implicitly is Agile. We've got sprints, 2-week sprints, in which you have, plan at the beginning of the sprint. That's done for you. I tell you what you have to do for the next 2 weeks. At the end, you have deliverables, right, for that phase, for that sprint. And then you have retrospectives, and I kind of take on that role as well by, posting a retrospective at the end of each phase. That's basically Agile, and Agile is intended to be a self-managed system where you've got software teams that decide what they're going to be doing for the next 4 weeks, commit to it, track their progress, and at the end they manage themselves and each other by saying, you haven't done any tasks according to our burn down chart. It's something. Burn down chart is you've got this amount of task and you've got a month to do it. So what should your progress look like? It should burn down to 0, right? You've got 10 tasks or 1,000 hours of tasks. Each day, that should be going down a little bit until you get down to the end of the month. A bad burn down chart looks like this because you got done with everything on the first day. Well, actually, that sounds great to me because now I'm going to go ahead and have fun for the rest of the month. But no, it doesn't sound good to management. That's bad self-management. Another bad burn down chart would be over here, we didn't get anything done, right? Or, it stayed up high and then only on the last day did we do a rush job and get everything done. That's also a bad burn down chart. You want a nice, steady burn down because that means that you are working at a steady pace. You don't have troughs of inactivity and spikes of furious activity, right? Don't put things off to the due date, basically, is how I've adopted it here. You have business requirements and design specifications. The business requirements are basically me writing up the project and giving you the business model, basically. But in real life, you would have to go to the stakeholders and say, what is your business? We're going to have to interview and find out exactly what your software needs are, right? And should we be supporting multiple emails in the system, or can you get by with one, all right? Asking them what their business rules are, interviewing them, sussing out all those business requirements, and then coming up with design specifications. And that's where your design document comes in. You are given the business requirements in the form of that handout. You are supposed to take them and design it using the design document for the design specifications. Use cases are where, how would a typical user use this system that we're building, right? And what would a successful use of this system look like? You write that up basically kind of as a story. And the user needs to be able to do this. This is how they go about doing that. And that gives direction to the implementation teams to, okay, well, then we need to model that, right? So that it's a successful use case. Testing, right? You're familiar with unit testing because there are JUnit tests on all of your labs. You could conceivably use them for your project. You're not required to. You've got integration testing where you've got two major system components that need to integrate with each other. Well, that needs to be tested. That goes beyond unit testing. Automated testing, regression testing, right? Regression testing would be, do we still pass? We made some refactoring. We changed some things. Did we break anything that was passing before? Performance and load testing, right? It might work on your computer with one user when you run it, but when you put it out to production and there are 1,000 people trying to hit your website, it can't handle that load, and we never tested for that load, we're done, right? It crashes. Ignore all of these except for Git. CVS, SVN, they are deader than dead. Mercurial would be another distributed version control system that I'd put up here, but it's also dead. Git won the battle, right? So learn to use Git, stick with Git. You will be expected to have Git skills going into even on the entry-level internship job, right? Build and deployment measures. Make, Ant, Apache Maven. We haven't really talked about most of these, and it's in fact, when you use Eclipse, it's kind of all opaque. Maven is actually running, Ant is running in the background to build your stuff constantly. You can, of course, script how your project gets built and deployed to a system. In fact, that's a job unto itself. It's called CI, continuous integration. The last private sector job that I had over 10 years ago, we had actually 2 full-time dedicated people to just this alone. They didn't write any code. They only wrote scripts to build other code, build and deploy other code, right? You also have to be a little bit of a lawyer, right? Legal and ethical issues. IP, copyright. Are we breaking copyright laws or are we breaking patents or licenses by using this software? Well, what license was it released under? GPL? Oh, we're good to go. We can use it for whatever we want. Oh, wait, no, it's restricted. We are making a profit, so we can't use that over there. It's not for profit license. And then, you get the lawyers involved or whatever. And if you're ever a private contractor, you need a lawyer. That lawyering and that legal stuff goes beyond your ability at that point. You need contracts. Privacy issues, accountability and compliance, Sarbanes-Oxley, NIST. And one thing that I would add here is equity, right? We know that in our industry, women make only up 30, at most, at any one time, 30% of all tech and IT positions. And there are plenty of studies showing that they are driven out of the industry at a much higher and alarming rate than men are. And so being aware of those issues, being aware of equity, it goes beyond just gender, it also goes to race. making sure that you are producing and supporting an inclusive environment is absolutely necessary. That goes into the ethical issue. If you're not doing that, then you are not acting ethically. Right? And many other issues. The bottom line here, with the 1 minute left, is a software engineer or software developer, whatever you want to call yourself, has to be a little bit of a lawyer. They have to be a philosopher. They have to be a diplomat, teamwork, right? They have to be a designer. They have to be a manager. They have to be a writer, technical writer. And last, and maybe least, they have to be a programmer, right? So that's giving you a little bit wider scope on what your futures may look like in industry, right? You might end up spending less than 10% of your time actually writing any code, right? Questions?
Yeah.
Here, I'll take it offline here since we've hit time. I'll go ahead and stop the stream. See you on Thursday when we transition over to data and structures and algorithms.